The University of Texas at El Paso College of Engineering, in collaboration with Halliburton, presents Hydronic Flow Simulator. Before using any machinery, make sure to wear the proper personal protective equipment. In real-world applications of heating, ventilation, and air conditioning (HVAC) systems, airflow is guided by duct work in the rafters of a building. Hydronic systems can supply the medium or fluid by means of various piping distribution methods, such as one-pipe, two-pipe, or four-pipe systems. Hydronics is the use of water or another liquid as a heat transfer medium. For example, steam or hot water radiators. Hydronic systems were used on commercial buildings only to provide for heating and air conditioning. The chiller boiler system innovation makes them available for homes and smaller commercial spaces. There are two types of hydronic systems. One, which is the steam or hot water, and the other one, chilled water. They can also be classified in 5 different ways: flow generation, temperature, pressurization, pumping arrangement, and piping arrangement. This can also be classified in one-pipe, two-pipe, three-pipe, four-pipe, and a series loop. For this experiment, we will be focusing only on the two-pipe steam, the direct and reverse return. A two-pipe system can be a direct return system or a reverse return system. The two-pipe direct return system takes the most direct path back to the boiler. The advantage of the system is the low cost of return piping in most of all the applications, and the supply and return piping are separated. In this system, once the water has left the first radiator, it returns to the boiler to be reheated. On a two-pipe reverse return system, the pipe travels to the last radiator in the system before returning to the boiler to be reheated. The advantage is that the pipe run to each radiator is about the same. This ensures that the frictional resistance to the flow of water in each radiator is the same. The pipes in the systems are used to simulate regional pressure differences as a result from the isolation of sections of pipe. Three different bulbs were used: isolation bulbs, balancing bulbs, which creates a balance within the flow caused by inconsistency in pressure from incoming flow, and a 3-union bulbs. The pump can produce 1/8 of a horsepower, and also it can produce graphical representations of the flow. Coils are used to radiate heat. Fans are attached to these coils for forced convection to speed up the heating and cooling process. Together, these components are called fan coils. A 6-gallon water heater is used, and it can keep a temperature difference of 70 degrees Fahrenheit. Water expands as it heats and contracts as it cools. For this reason, an expansion tank is necessary in the system to accommodate the varying volume of the working fluid. It also helps to maintain a constant pressure in the system. All hydronic systems must have a means to eliminate air from the system. Air causes irritating system noises, as well as interrupting proper heat transfer to and from the circulating fluids. Besides, the oxygen dissolves in water and causes corrosion. Thank you very much for watching. If you like this video, give it a thumbs up and subscribe.